Today's exercise 11B and C, what we're dealing with is indefinite integrals is what it's called. What we're going to do now is we're going to fill in a couple of notes here. Differentiation finds the gradient function. So you now know every time you find the derivative, you're finding a function, but it's the gradient function. It's a function that allows you to find the gradients at any point of the function. So depending on whatever curve or function is, the derivative tells you the gradient function. Anti-differentiation finds the function from the gradient function. Okay, so what function, if you derived it to give you that gradient function, the antiderivative literally means to go backwards. Anti-differentiation is also referred to as finding the indefinite integral, and you'll find that later we'll do definite integral, so the difference between the two. But at the moment, we're working on just some anti-diff skills. These are some of the notations. Some things to be aware of for the exam. When you're writing the antiderivative, if you do not include the dx, you do lose a mark, okay? Because they actually mean something. That's actually if you think of the rectangles when we're doing the areas, for example, one is like the height and the change of x is the width. Okay, so it's the idea that what if we made infinitely smaller x's, so more rectangles to find the area under a curve, times by f of that value, that's what you're actually getting, the area under the curve, right? So that dx is important. That tells you what respect to. Oh, that's probably music room. Here are some of your rules. Now, some of these rules you would have seen from last year, and you might have remembered. If you don't, these are worthwhile to refer to. Usually it's already in your formula sheet at the end of year. Essentially, they are just the reverses of your derivative rules. So, for example, this one is the reverse of power rule. So if you think about power rule, it was if you have f of x is equal to a times x to the power of n, the derivative is n times a to the power of n minus 1. Well, that a is still at the front, and then you times by the power. So when you're doing the reverse, you're then not going to times, you're going to divide, hence why they have a divide. But instead of minus 1, it is now add 1. That is why they're moving backwards. It's essentially the reverse of the power rule. Similarly with the second one, that's also another sort of idea of you use chain rule for your function. So for example, if I gave you 3x plus 1 squared, you would have used chain rule to get this, and you would have derived the inside. That's why you multiply the front by 3. Well, then here you can see you're also now dividing by the coefficient. Okay, so it's a sort of reverse chain rule in a way for the power function. If all that is confusing to you there, maybe worthwhile. That's the exercise that we're going to be practicing. Okay. Note though, there is a general confusion, and for a while in your past exams, for exam 1, I think it was question 1B or 2 usually, they usually mix between this one and this one because they look very similar. You see that they've both got ax plus b to the power of n. The difference is, if I rewrote this one, this is actually the same thing as writing ax plus b to the power of negative 1. This is why there's a condition here, and it says if r, which actually that should have been n, usually in your textbooks it's r, but that power, if the power is negative 1, it is a log. But if it's not a negative 1, so like negative 2, negative 3, then that's essentially your power rule. Okay, so if you remembered back in derivatives, we know that if you have the function log base e of x, then the derivative is equal to 1 on x. But that is actually the same thing as writing x to the power of negative 1. So when you have an antiderivative where you've got an x to the negative 1, then it comes back to log. Whereas anything else, like x squared or x negative 2x cubed, the anti-diff, it's either the reverse of a power rule or reverse power rule with chain rule. Okay, so those two, 2b and 4b, commonly mixed between the two. another thing in the exams, when they do chuck it in, they like this one, 4b, because there are two possibilities. When you antiderive them, there is what they call an absolute value. You guys don't learn modulus anymore, but it used to be that when you find the antiderivative of, say, 1 on x, it actually equals to log e mod of x. And what that means is you could have log e of positive x or log e of negative x if you find the derivative of them. So for example, we work backwards or forwards. If I gave you log e of positive x and I said find the derivative, you'd say it's 1 on x. But if I gave you 1 of x, f of x equals log e of negative x, and I said find the derivative, you'll find that the answer is also 1 on x because the double negatives will cancel out. So here, if you find the derivative of the inside, it would have gave you a negative 1 times the derivative of log e of 1 negative x becomes 1 on negative x, and conveniently, the double negatives cancel out, and you end up with 1 on x. So that means when you do anti-diff, when you anti-diff 1 on x, it could be log e of negative x, or it could be log e of positive x. It's kind of like your square root, so when you square a negative number, you get a positive value, and you square a positive value, you get a positive value. So when you square root, it could be either plus or minus. Same thing with anti-diffing. If you anti-diff a 1 on x function, it could be a positive log, or it could be I shouldn't say positive log, it should be log of a positive value or log of a negative value. Okay, so that's what examiners had in the past enjoyed putting in consistently, because that was one that tripped up students for a while. But I think they've put it so many times now that it's a given fact that most students will know, and they can pick that up. So the percentages of correctness has gone up, and I don't think they put that as often. So they'll probably chuck that in with something else or some variation of it rather than a just direct anti-diff. Okay, but just put a note for yourself so that you know that you at least practice these two to know the difference, and then try some exam questions to know how they would test it. Okay? All right. Let's answer a couple of notes here. So another examinable thing that they do like to do as well, notice the questions. They either say find an antiderivative, or they might say find the antiderivative. There is a difference between the two. In the exam, they can penalize you depending on how you answer it. So if they say an, which refers to a singular value, you can choose the value of c, because it's not a family of possible curves. It's an, so meaning one. And often, you can just say c is 0, because that is an antiderivative. It is an answer where c is equal to 0. So in other words, when they say an antiderivative, it is possible to not include c, because we are saying c is equal to 0. But when they say find the antiderivative, then you must include the plus c. Or they might ask you to find the actual value of c. Okay, so just be careful of those. If you go back to the past exams, you'll also notice how they switch between the two as well. An antiderivative versus the antiderivative. Okay? So the means include the plus c, and don't include, or you can use any value, and technically it's true. Okay? All right, let's do some practice then. So if you got the rules in front of you right there, let's do the first two, and then I'm going to give you some time to try the back page because it requires a bit more practice there. Let's try this one. Note the condition that is on purpose there. X is less than 4 on 3. Here we go. Antiderivative. So it says the antiderivative. So do you include the plus c or do you not include the plus c? You include it. Okay, so let's find the antiderivative of negative 2 over 3x minus 4. Don't forget, delta x. Okay, that's your first layout. I usually like to take out the negative 2's because they're multiplying to the function that's a constant that I can multiply outside. So I'll take out the negative 2, and I'm just finding the antiderivative of 1 on 3x minus 4. Now, this is the bit that you need to decide. Okay, which of the rules that you have on your table there should you be using? Is it 1, 2a, 2b, 4a, or 4b? Which one are we doing? Rango. You do 4a or you could do 4b. Yes, actually 4a and 4b are technically the same type of function. It's just one has no parameters for x and a constant there. So I would use 4b just because it's more generalized. Let's use 4b. So looking at 4b, my a is currently 3 and my b is currently -4. So according to the rule, when you're finding the antiderivative of 4b, knowing your a's and b's, what is the possible answer here? So you should get -2 times. Who wants to have a go? So a is the coefficient of x. Yep. Joe? 1 over 3, because that's 1 on a. According to the rule, it was 1 on a. So notice here, that's a 1 on a there. Good. 1 on 3. Natural log, so we can do ln or log base e. Up to you. 3x minus 4 plus c. Make sure to put a modulus. Because remember, when you do the antidiff of this type of function or rectangular hyperbole, you could be log of a positive number or log of a negative number. But usually that would be where you finish. They did give you a condition though. Since x is less than 4 on 3, okay, which really, if you think about this condition here, 3x minus 4, you either have it positive or negative. Now, if 3x plus 4, 3x minus 4 is less than 0, we can already see that it would be 3x less than 4 and x is less than 4 on 3, which actually fits that condition. That means this section here must be not a modulus because we know it's not the positive version. If it was a positive version, it would have been x greater than 4 on 3. So your answer should be -2 times a third, which is 2/3, log base e of, and it's the negative version of 3x minus 4. Okay, because we said 3x minus 4 has to be less than 0. So negative version, so negative of the 3x minus 4, whatever that is, it's going to be the negative of that. That gives you 4 minus 3x. So inside it, it should be 4 minus 3x. That represents the negative version of your log rather than the positive version. Okay, so you can either have the positive version, which is 3x minus 4, or you can have the negative of whatever 3x minus 4 is, which is 4 minus 3x. But given the condition, we know it has to be 4 minus 3x and not 3x minus 4. Okay, so a little condition there to be careful of. So as you're doing your questions in the exercise, just be careful if there's any restrictions. Otherwise, you must include both possible answers. Kind of like your square root. When you square root 9, you have to write plus and minus 3. And then depending if they tell you x is greater than or less than, then you choose one or the other. Okay? Questions on that one? This part here? Yeah, so this symbol, when you write mod of, what happened there? 3x minus 4, this is equivalent to you saying you have the positive version of the value, which means whatever 3x minus 4 is, if it's positive, then it's already positive, right? So that means this is for when 3x minus 4 is greater than 0, which essentially means x is greater than 4/3, right? But when x is less than 4/3, whatever this value is, we know it's going to be the negative of that. So hence it's negative of 3x minus 4, which actually ends up being, that's minus 3x, and that's a plus 4 there. So this means that there's two conditions there depending on whatever x value is. So if x is less than 4 and 3, this is the value that will function for it. It's a hybrid function, essentially. Yeah. And that's what modulus means. So in the past, we learned more about this. So when you do mod x, for example, that was the original function. We used to teach students that this means it's positive x when x is greater than 0, and then it will be the negative when x is negative, like that. So by that same definition, you got the positive of the x value or the negative of the actual x value. And that's when it's positive or that's when it's negative. And then technically the graph, that looks like that. And that's where, so when it's less than 0, you sketch this graph. And when it's positive, then you sketch that graph. And what you see here is the y values are always positive. And that's what that represents. This is meant to talk about the absolute value. It doesn't matter about the signs. We take just the values itself. So that's why it's symmetrical. Yeah. Yeah. So they took that away, but expect you guys to know, in a way. All right, team. Next one. And don't forget to put the plus c because it said find the antiderivative. Make sure to have the plus c. All right. Next one. Who wants to have a go with this one? So find an antiderivative. So find an antiderivative. Do you include the plus c or not? No, you don't have to. You can use any other value. If you use c equals 0, then you don't have to put the c value there. So 3x minus 5 to the power of 4. Don't forget dx because it's respect to x. Who wants to have a go with this one? Ryan.
1/15.
Ooh, how did you get the 1 on 15? Where did that come from?
It's the 1 on 3 times 5.
I'm just going to write it like this, just so it's a bit more clear. And then you got 3x minus 5 to the power of? Good, so 4 plus 1. So if you're going back to rule 2b, you should see there was an a value. This is your a. Here's your a equals 3. So it should be 1 on a times 1 on n plus 1. So n is the power, so 4 plus 1, n plus 1, and you've got the function there. So putting it all together, 1 on 15, 3x minus 5 to the power of 5. Okay, and you don't have to put the plus c because we're saying c is equal to 0. So assume c equals 0. So you don't have to put the plus c, and that's an antiderivative, not the antiderivative. All right? Now I'm going to pause the video. The next 2 questions may challenge some of you just to get you thinking a bit. But I'll give you, maybe 5 minutes to have a go with example 3, and then question 11C, exercise 11C, question 10. See if you can do that question there. I'm going to pause the video. Here we go.